Hey team, we're back for round two, and most of you seem to enjoy the video for week one. Hopefully you did okay with that stuff. Some of you got a hold of me, asked your questions, and that was super good. If you need anything, make sure you're letting me know because I don't know if you're struggling unless you talk to me. So I'm available for Zoom videos. If you want a video chat, I can help you through your homework. Or if you just email me, I can walk you through via email. Whatever you need, I am available. I am here at my house, social distancing my life away. So let me know. Whatever you need, I got you. So hopefully you got your Unit 1 test done before you're doing these. If you haven't taken your test, go take it. Send me your scratch paper and I will get your tests graded as you get them done. This is the start of Unit 2, and Unit 2 is fairly short. We're just going to do some graphing, and if we were in class, I would not use my math lab because I think my math lab makes graphing way easier than it should be. Because if you're graphing stuff by hand, it's so much trickier. So this is actually going to be pretty easy on you guys. So lucky for you, you get my math lab to crutch on. So we're going to roll through graphing actually pretty quickly since you have my math lab to help you out. And I'm going to kind of flip between screens here, so bear with me as I try to get this to work because I'm going to do some Desmos stuff to kind of let you see how this works. And then I'm actually going to flip over and do a homework problem for you so you see how it works on my math lab. So away we go. When we're graphing sine, the sine curve is always going to start at 0 unless we move it around. But y equals sine x always starts at 0, goes up to 1, back to 0, down to -1, and then ends at 0. And so a full cycle of the sine curve takes 2 pi to happen, and we call that the period. The period of sine is 2 pi, and then its amplitude is 1 because it goes up 1 or it goes down 1 from the middle. Its x-intercepts are 0, pi, and 2 pi. That's where it crosses through. Domain, it goes on forever, left and right. And then range, it always stays between -1 and 1 unless we change it around. Cosine's going to look really similar to the sine curve. It's actually just moved over a little bit. So just like sine, its amplitude is 1 and its period is 2 pi. It takes 2 pi to make a full cycle. But cosine starts up here at 1 and then hits 0, goes down to -1, back to 0, and ends up at 2 pi, right up there at 1 where it started. And so its x-intercepts are at pi over 2 and 3 pi over 2. It kind of looks like a cup or a bowl or something. I don't know, whatever you're into. Just like sine, domain, and range are the same. So that's what your sine and cosine curves look like to start out. But we can change them around, just like we can change any function. We have this letter out front. If we're multiplying sine or cosine, we call that the amplitude. If there's a number in front of the x, a number multiplying the x, we call that the b. That affects the period of the graph, how long it takes it to make a full cycle. So the period of your function is always going to be 2 pi divided by whatever that b value is. If we're adding or subtracting a number with the x in parentheses, that's called your phase shift, and it's your horizontal shift, left or right. And it's always the opposite of what the sign says. So if it's plus, that actually means you're moving it backwards to the left. And if it's or backwards to the right, God, I don't even know. No, I was right. It's left. I'm struggling, guys. It's Monday. If it's plus C, like if it's +5, that actually means you're going to move backwards to the left. And if it's minus C, like -5, you're going to move forwards to the right 5. And then that D value, if you've got a number being added or subtracted to that whole function that's not in parentheses with x, that's your vertical shift. It just moves it up or down exactly like it looks like. If it's plus, it goes up. If it's minus, it goes down. And if you're like me, that just was a whole lot of math gibberish. So I think it helps if you actually see what this looks like. So we're going to hop over to Desmos and look at it. So we've got this regular old sine function. Starts at 0, goes up to 1, back at pi, it's at 0. At 3 pi over 2, it's at -1. And then at 2 pi, it ends at 0. And it just goes on forever like that. So my a value out in front stretches it up or down. Just depends on how big we make it. But it makes it bigger or smaller if it's less than 1. Like if I make it 0.5 or 0.4, it makes it real small. So we'll set that back to 1 where it was. Your b with the x changes the period of the graph. So the bigger I make it, the closer together it gets, the less time it makes for it to make a period. If I make it less than 1, it's going to take it longer to make a period of the graph. But it's always 2 pi divided by whatever that b value is. That c is going to move it to the left if I have a positive c, or to the right if I have a negative c. And then our d, or this is a k because that's what they wanted it to be, moves our graph up or down. If it's positive, it's up. If it's negative, it's down. So that's how those things change your graph. So a changes amplitude, b changes period, c moves it left or right, and k moves it up and down. So there's lots of ways to change it. And you can also change your cosine graph the same way. Cool. All right, let's go back to our PowerPoint. We also have the tangent graph. Tangent looks nothing like sine and cosine. They have nothing in common, really. There's no amplitude to tangent because it goes up and down forever. Tangent always starts at 0, and then it has a period of pi. So your next intercept is at pi. Halfway between those, at all the pi over 2's, you're going to have asymptotes. Don't touch them. It's not polite. So you have asymptotes every pi over 2. Your graph for tangent goes up from left to right. Domain is going to be -infinity to infinity except for those asymptotes. And your range goes on forever, up and down. So period for tangent, instead of doing 2 pi over b, you're going to just do pi over b. Tangent happens half as often. Cotangent is going to look pretty similar to tangent, except everything's opposites. Instead of having points on the pi's, you're going to have asymptotes on the pi's. And instead of having asymptotes on the pi over 2's, you have points there. And instead of going up, your graph goes down. So everything's opposite for cotangent. But again, no amplitude. Period is going to be pi over b. And then just your x-intercepts and your asymptotes are different. Secant and cosecant are based off of sine and cosine. So if you're graphing cosecant, you graph your sine graph first. Whatever, if you have y equals 7 cosecant x, you graph 7 sine of x first. Just pretend that that cosecant is a sine and you graph it. And then wherever your x-intercepts would be, those become asymptotes. Don't touch them. And then wherever there's a peak, that becomes flipped, it becomes a U. Wherever there's a valley, flip it, that becomes like an upside down U. So that's what cosecant looks like, that purplish blue graph. Its period is still 2 pi because it goes with sine. And then secant, you graph your cosine. Let's just say cosine. Sorry guys, I messed up. So it's going to start at 1, and then pi, and then 2 pi. Again, you have asymptotes wherever your x-intercepts are, and then you have your u's. So that's it. That's the notes for this section. You're ready for your week 2 homework. Make sure that your unit 1 test gets done. And I'm here, whatever you need. And I actually want to go through a homework problem with you because these are a little bit different than maybe what you're used to. Like I said, I don't love my math lab for these because it's just so easy. You guys are in for an easy time. So let's go to my math lab and do a problem. Man, that's just so cool. Look at it go. Okay, I'm going to stop it. So if we go over to my math lab, I am going to do number 9 with you because number 9 is probably the trickiest one of all of them. So it wants you to graph 5 sine of 1/3 x plus 2. This one's got a lot going on with it. That's why I picked it. So what you do on these is you're going to click on the graph and you have to decide what kind of graph you want. So if you look down here and hover, there's a sine tool and there's a cosine tool. Since this is a sine graph, I'm going to click sine, and you can click anywhere on your graph. It's going to make a sine. And then it brings up this vertical shift, horizontal shift. And so I know I want, there's a +2, but it's not in parentheses. That's a vertical shift of 2. And that's it. That's all we have to do on these because I notice that it's got the correct amplitude of 5 and a period of 2 pi over 1/3, which would actually be 6 pi. You notice that's how long it took to make that. Click check. And that's it. That's all you have to do on that one. Okay. So if we go back, my computer's being wacky. Sorry, guys. Let's go back to like number, let's do a good one. Yeah, let's do this one. Number 3, it says determine the amplitude in the period and graph it. Okay, so the amplitude's the front number, that's 4. Hooray. The period is 2 pi over 4 pi. 2 pi over 4 pi, the pi's cancel. That's 1/2. Hooray. And now we graph. Come over to my graph. I click sine. Okay. Well, that looks kind of weird. So I need to change my amplitude to 4. And I need to change my period to 1/2. If you need a pi in there, you can literally type pi and it types pi, but we don't want pi, we just want 1/2. Enter. There's no shifts or anything. Check your answer. Hooray, you're done. Cool, good, happy. I want to show you something I found on number 1 because I got number 1 wrong because number 1 has something whack to it. Okay, I'm going to similar question number 1 for you. So you type in your amplitude. Amplitude's the front number. Okay, cool. You click your graph and you're like, okay, sine, cool, done. Amplitude, we're going to change amplitude. Feeling good. You check your answer and it says you're wrong because it wants you to also graph the regular sine. All you have to do is hit the sine, put it on there, and then check your answer. I don't know why it wants both. It's just the way it is. Sorry about it. I don't make the math lab rules. So you should be good to go. Let me know if you need anything. I'm here for you. You've got this. Let me know if you found any sweet Netflix shows or anybody dropped any sick beats. I'm here for it. Have a good week. Do your best. I miss you.